Welcome to SFAB, Science for a Billion. I am your host, Amna Khan, a postdoctoral researcher at Brookhaven National Laboratory. I'm really excited to have our guest here today, Professor Sumathi Rao. She's a theoretical physicist working at Harish-Chandra Research Institute in the field of condensed matter physics. She has an exceptional journey, including IIT Bombay, Stony Brook University, Fermilab, Institute of Physics, and TFR, and she was an associate of Abdus Kalam ICTP Institute, and there are a lot of other fields that maybe I have institutes that I have not mentioned. And she is also a divisional associate editor of a very good journal, which is very well-known journal in natural sciences, Physical Review Letter. And welcome to Professor Rao to this episode. We are very honored to have you here.
Thank you. Thanks.
So your research topic include many fascinating areas of physics, the wonder material graphene, the quantum states of matter like quantum wires, as well as topological materials. So can you please explain your research in simple words for our audience? Because we want to give this message to, let's say, undergrads and high schoolers. So in layman terms, how you will explain these terms?
Okay, let me start with trying to tell you what I'm currently working on, which is topological materials. The word itself may be very, may not be familiar to most of you, but let me try to make it, try to say it in simple words. You in schools, you study atoms, molecules, you know that they get organized into and become different kinds of materials, such as metals, insulators, conductors, semiconductors. These are all things that you might be familiar with. In fact, you may even be familiar with the fact that under kind of extreme conditions, like very low temperatures, you may have heard of things like superconductors and superfluids, right? Now, when we say that we want to work on topological materials, these are actually different kinds of materials that you can now create. You can think of them as maybe made up from different compounds. And they have very different properties from the properties of these conductors, semiconductors and all. For instance, you know that insulators don't conduct electricity, and conductors conduct electricity. But these topological insulators have a very strange property. In the bulk of the material, they behave as if they're insulators, but right on the surface, they can conduct electricity. So it's as if you have a block of wood and it's covered with a metal, but actually the entire thing is just one material. By itself, it behaves as if there's a conductor inside and as if there's an insulator inside and a conductor outside.
That's really interesting. Yeah.
That's a very unusual kind of a material. And similarly, I mean, they can have these the reason we call these materials as topological materials is because there is, again, a very strange property that these materials have. They're kind of very stable under different kinds of what are called perturbations, different temperatures, different impurities, etc. And you can think of them, the reason we call it topological is that you can think of, you might be familiar with Play-Doh or plasticine.
Yes.
Right? So you can think of making a ball out of it. Okay. And on the other hand, the ball can be made into a flat disc. It can be made into a bowl. But as long as you don't punch a hole into it, it belongs to what is called one topological class. Okay. If you punch a single hole into it and make it into a donut, it belongs to a different class. Yeah. If you make two holes in it, it belongs to a different class. And what happens with these materials is that not in real space, but there is something called momentum space or reciprocal space, which some of you may be familiar with. It's like if you think of position and momentum, they're in two different spaces, right? So you can think of a space made by momenta. And in the momentum space, it's as if these objects, these topological insulators, are get classified into different classes depending on whether you have 0 holes in them, 1 hole in them, 2 holes in them, right? And these different classes are different topological classes. And that's why these things are called topological materials.
Okay, that's really fascinating. I mean, how are these research areas so important? Like, what are the applications? This is very theoretical material, like as
Yeah.
of my understanding. So, like
Yeah.
future applications or how it can
Yeah.
impact the life of a normal person, or as a researcher also, how it can change the fields. Yeah.
Actually, many of these fields, because of their properties of conducting electricity and heat, they can be used in very many. I mean, once enough research is done on them, it's like graphene as well, which many of you may have heard about, which is a wonder material.
Yeah.
Right? These things can be used in different kinds of uh, um, objects that you can make. Like earlier, what you used to make out of semiconductors and all, or metals and in conductors, you will have different properties if you make them out of these kinds of objects. They also have what very interesting what are called excitations. I mean, and by excitations, what one means is that you know electrons.
Yes.
You're familiar with electrons, and inside materials, these are actually kind of renormalized electrons, and they're called quasi-electrons. But usually earlier people only knew about electrons, which are fermion-like excitations, or other kinds of things like phonons and all, which are boson-like excitations.
Yes.
But with these topological materials and what people realize that you can also have excitations which have fractional charge and fractional, what are called fractional statistics.
Mm-hmm.
So these are neither fermions nor bosons. They're called anyons. And they have very unusual properties. And what is important is that these kinds of unusual properties become very useful when you want to form qubits. Many of you, again, may have heard of quantum computers.
Quantum computers, yeah.
Yeah. Quantum computers, just like the normal computers are made of bits, quantum computers have qubits. And these kinds of unusual statistics particles can be kind of, it's expected that they're relevant in this, making these qubits. So again, in the long, and the fact that they have this topological protection means that they're very stable. And so they can be used very easily. So in the long run, I mean, this will take some time, of course.
Yeah, I mean, but that's really fascinating. Yeah.
Yeah.
Yeah. Okay.
So these are things which can happen in these.
Okay. So taking a step back from your research, can you give us a glimpse of you as a high schooler or undergrad? So what made you pursue physics as a research career, or let's say as your career as a researcher, then you become a professor. So how was you as a high schooler? I want to look like as a glimpse of it. Yeah.
Yeah, I used to be, I would say, reasonably studious and kind of focused on grades and so on as a youngster, as a high schooler and so on. I liked physics because it seemed very logical and you could get answers to questions.
Yeah.
I liked logic, puzzles, detective stories, that kind of stuff. And basically, I mean, yeah, when I was very young, I wanted to be a detective because I wanted to find out things, right?
That's fascinating.
Yeah. So it's like children often, I mean, like you read books like the Enid Blyton and all. You want to find out things. You have clues, you want to find out things.
Yeah. Yeah. Mm-hmm.
So physics to start with seemed like that and I used to like puzzles of Scientific American, Martin Gardner, those kind of things. Number puzzles. So
Okay.
that was my interest in science and physics and mathematics. Then later on, when I became, when I was before I went into college, I think I got a copy of this Lectures in Physics by Feynman.
Feynman, yes.
Which I was very fascinated by. And it seemed again like something where you don't have to know things, you can always start with the basics and figure things out.
Yeah, it's similar like detective do. So that's a very good choice.
Yeah, exactly. I still love detective stories, detective serials of all kinds.
Okay. That's really, I mean, that's really fascinating to know about you. So you came back to India after your PhD and joined academia. How did
Yeah.
you make that decision? So, like most of us, as a, like I'm also a postdoctoral researcher, most of us wants to come back to India. So, what is the advice for young researchers who come back to India? How difficult it was for you? So, like, can you give us thoughts about it?
Yeah, actually, I mean, okay, even when I went abroad and I stayed there, I always wanted to come back to India because for many reasons, including the fact that somehow India always felt like home. I
Oh,
was never completely at home abroad, although I enjoyed a lot of my aspects of uh, studying, and as you must too, right?
yes.
Yeah, there's a lot of very positive aspects, and this was I went in 79, so this was in the 80s,
Thank
most
you.
of
Yes.
my career I came back in 87. So, um, but I always wanted to come back to India. I got married in the US. My husband is also an Indian. And we both had the view that we wanted to come back to
Come back.
India after postdoc. But probably we did not realize just how hard it would be because in US, even though we had a commuting marriage in US, one had telephones, not mobiles those days, but normal telephones. One could fly from one place to another, even though even in US it would take time. Whereas when we came back to India and we got jobs in two different parts, he was in TIFR, I was in Institute of Physics, Bhubaneswar.
Ishwari.
There are two different parts of the left, east, and Bombay in west, and
Yes.
Bhubaneswar
Yes.
in the east.
Yes.
And flights were out of the question. They were more than a month's salary. So we used to take trains, which took 36 to 40 hours was the normal, I mean, the correct
Oh,
uh,
okay.
thing. But I remember one particular time trip took me, I think, 60 hours to
Six.
go between. Yeah.
Okay.
So these were really, I mean, long travels that we had to do. There were no telephones in either place.
So
And
things are changing now. So I
yeah,
mean, now it's very well advanced. So what
exactly.
advice you will give to the young researchers who come want to come back to India? What the opportunities India has to offer them? Like because a lot of people have these thoughts. Like even if I say tell someone that I want to come back to India, then I'm working on accelerator physics, then they are like, oh, there is no good accelerator in India. So why do you want to come back to India? So these kind of thoughts. So but
Okay.
like what
For a
India can
theoretical,
offer?
yeah, yeah.
Yeah.
For a theoretical physicist, it's certainly easier to come back to India because right now, given the fact that you have internet everywhere,
Yes.
it may be slower, it may not be as stable, but you have it.
Yeah.
So I certainly think that for a theorist, it's much easier to come back to India. You lose out on contacts, you lose out on maybe some aspects of working with others who are doing experiments and so on, but certainly it is possible. Even for experiments in some fields, in a lot of fields, now they are trying to put a lot of money in it. So I would say that our prospects are good. For accelerator physics, I'm not so sure, but probably the point is your experience in accelerator physics can be utilized in many other things as well.
Yeah. Yeah.
So
Yes.
my advice to people coming back to India would be to be a little more open-minded about what they want to do.
Want to do.
There
Yes.
are a lot of, I think there are many institutes which are coming up, ISERs, IITs, universities, where they are opening up to sciences,
Yes.
and they are looking for people. They are looking even for experimentalists. But if you want to focus on the same kind of work that you did abroad, that may not always be the possible or even be the best idea. But
Exactly.
I think as long as you're slightly open to, and although you can't keep your contacts these days by traveling and so on, but still it would always be a good idea to keep an open mind and get into different fields. And
Yes.
I would say that there's so many challenges now in India
Exactly.
that, yeah,
So
and,
there's a lot of
yeah,
opportunities that.
there's a lot of opportunity. I
Yeah.
also want to mention one more thing. I think it's really important that a lot of young people who are rational, logical, come back to India. I mean, I think all of us know now that given the kind of sway that religion, politics, all these things have in India,
India.
it is important that people who can think for themselves come back.
Come back to India. Yeah, because for a lot of people, this is the thing that they are like, okay, now India is going in another direction. We don't go to back to India. So that's a really
Oh
good
no, I would
strategy
really say I
to, yeah,
hope that many more come,
many
but
people
I would say that it would be good if people come back in numbers.
come back.
One and two people. When we came back, it was a little hard, but still, at least there was around the time we came back, some other theoretical physicists also came back, so
Yes.
we could form groups. So I
Okay.
think now, if many people come back at one go, because a lot of the problems in India are not to do with money alone.
Yes.
To change bureaucracy, to change administration,
Yeah. The
numbers matter,
mindset. Yes. Yeah.
right?
I agree. So, okay, let's come back to the point. So, as a professor, I mean, you have plenty of jobs, like because our researcher journey is not always so good. We have downsides also. So, how your students play the role, like how you get motivated, how you achieved so many things, like throughout your lifetime. What was your experience? I would really like to know about that.
Yeah, I would say that. Uh, there were kind of experiences where I actually did not have a very good time when I first came back, and I had to change my field, and there were personal reasons and so on. And so, what I found is that in India, it helps to become senior, it helps to become older, it helps to have students. And students, I think when you change your field, there are good points about it. One is that you learn new things.
Yes.
You bring a new way of looking at older things, so that actually helps. At the time I moved from high energy physics to condensed matter physics, a lot of people were doing it, and a lot of our what we learned as a high energy physicist, the theoretical aspects that I
Yes. Mhm.
with group theory, topology, and all are now being used in condensed matter. So it was not a waste. What you learn is never a waste,
Never waste.
right?
Yeah.
But what you do lose out is that your contacts. My contacts abroad, my advisor was from high energy. My other contacts, my postdoc contacts were all from high energy. So I didn't have them. So I had to start from scratch. So
Uh,
that way, life was difficult. But where I found that it became a little easier is once I started having students, because they kind of, and even if you are down, depressed, this thing, it helps to have someone first, to feel responsible for someone, then you're forced to work.
yeah.
You can't slack off. Two, it's a kind of a synergy, right? They also get enthuse you, you enthuse them, and then it's like a synergy. It works together. And I was lucky that I got some good students, very good students, and I also learned because I myself had kind of, people had put me down and all when I was younger. I knew that what is most important is that people believe in themselves.
Yes.
So, as a mentor, I realized that all one had to do is tell the students how good they are, and they'll do it all. You don't need to help them; they'll do it themselves. But
Yeah.
they have to know that they can do it.
Exactly. Exactly. So I mean that's really inspiring how you change your field and still you are very well accomplished in your field. It's really interesting. People should look into your story that it's everything is possible even if you have some downsides. Still there is a good end
Yeah,
to this. Yeah.
very good at it.
So there is another story, like you have been involved in women in science since 2000, and you have been quite active on it. I read a lot of articles that you wrote. So what are the challenges that you think women face in STEM, and how easy or difficult it was for you? Like how your perception changed that, okay, these things exist. Like initially, even I thought that woman in science, it's kind of a like, okay, it's just a gang, but but then I think so with time I'm also realizing it's true, it's there. So maybe what are your thoughts on that?
Yeah, I think many of us, particularly from India and all, and many of us go to girls' schools and all that, we don't really realize initially that there are, because nobody tells you you can't do science. In the West, that is more common. But in India, I don't think either from my family or school or anywhere, I had the impression that I could not do science. They assume women and men both can do science, right? So that's, and then when we went to IIT, there was, I think, discrimination. But because again, we lived mainly in the girls' hostels, we didn't realize it. I mean, we were sufficient to ourselves and we were happy in ourselves. In some sense, you're also focused on your work. You don't think of these things, you don't realize it. And in fact, for us, that went on quite a bit. And for many of us as individuals, we all faced setbacks in our careers. Myself, other women. I thought in my case it was because I was married to a star and that's why people put me down. Somebody else thought some other reasons. But for every person, until we went and saw some certain things collectively, we didn't realize that there is a systematic this thing downgrading of people do try to put and don't take women so seriously.
Yeah.
Right? Even in fact, students have earlier told me that when women teach them, they feel like they're back in school. They've only been taught by women in schools.
Women in schools, yes.
Yeah. So and they feel that their ego gets hurt if they're corrected or scolded by or something by women. And then other guys around also, they always feel that they have to be one up. I mean, they know better, right? That kind of thing. So those things, what you realize is that initially you don't realize because you're kind of focused on your work and you don't have that much time to think of all that as you
think of all that. Yes. So this bias is there, consciously or unconsciously. Still, there is something.
Yeah. And afterwards, when you're in selection committees, when people ask things like, "Oh, she's going to be married and she'll not come
back," yes, yeah.
She's going to have a baby, so she's not going to be. You don't take them seriously. Then you realize that people, you need some kind of
some kind
of a collective way to change these attitudes.
Yeah.
And I think what has happened in the last 10, 20 years in India has had a lot of kind of schemes for women coming back to work after children and all that. DST and all these places have it. It's, I would say, still a little paternalistic. I mean, it is not, then they're kind of still not, they're given DST jobs or something like that. But it doesn't mean that the rest of their colleagues will take them seriously.
Yeah, that's the whole point, that they don't consider them equal. So,
for students. For that, you actually have to, you have to work very hard to be taken seriously by people. And those things, social changes will be very slow. As everyone knows, right? Yeah. You can't expect them to change overnight. And the only way you can change it by enough women taking physics, science very seriously. Not just as a woman scientist, but as a scientist.
As a science, yes. Yeah. Right? So we need a lot of people that like the motivation needs. I think so. It's very important that it should be there at their high schools or when they're undergrads, that they need to be motivated. Like if I remember, we had a lot of girls or as a woman in science during my bachelor's. I did my bachelor's in Punjab University, and then when I was in IIT Roorkee, so there were only 4 of us. And then I went to Germany to pursue my PhD. I was the only one in a group of let's say 25 people. So so these things.
So and it's not just marriage which stops people, but with this a major thing, I agree.
Yes, yeah.
But also their motivation has to be strong enough, and they have to be.
Yeah. So you mentioned that, I mean, like we already discussed the scenario that it's gradually changing in India regarding women in science. So what do you think is the role of family in terms of supporting their child, especially the girl child? I mean,
Yeah,
it's like even a high school, like even if you are in a IIT and for a man also, if they're studying science, then a lot of people are like, why didn't you want to be tech? Or why don't you
yeah,
take a job? And why do you want to pursue science? Like waste your, people usually say this thing, waste your 10 to 12 years. And
yeah,
then still
yeah.
you will be, there is a chance that you will be jobless. And
Jobless.
what, how we can change this? What is the role of the family that they can support? What are your message to them?
Okay, family for girls, of course. I mean, okay. Uh, in general, of course, I agree with you that both for boys and girls, people should change this idea that, I, understand that physics is also a career choice. We used to say things like we go to schools and all and try to motivate students. Then we tell them join physics and see the world.
Yes,
Among other things, physics is a global enterprise, right? Right? You may not make money, a lot of money, but you live a reasonably good lifestyle.
reasonably
If you
good.
can get a faculty position, the life is actually not at all bad. So that is something we try to get across to many people.
Yes,
For girls in particular, but what I see is that there is a lot of regional differences. Uh, I think, I mean, in places like Uttar Pradesh, where I've been for the last 25 years right now, it is true that people do not treat girls and boys
equally. Yes,
equally at all. I mean, many of them are not at all encouraged to. I mean, you do need a certain amount of encouragement from home to take yourself seriously and to go for work, study, work, everything, right? It's a
yes,
little better in South and in the metropolitan cities and so on, Calcutta, Bombay, Delhi. But many of these places, I think we still have when the families have to learn a lot.
a lot. Yes, yeah,
And
because
that I and yeah, and this is first to start with as children.
yes,
Then,
yes,
of course,
because
when it comes to marriage and child care and all that, I mean, men have to be trained a lot.
trend. Yeah, yeah, it's not only women; it's also men.
A
So
lot of the men have to be, they have to be brought up from childhood to see that girls as their equals, right?
exactly.
In fact, many of these things are becoming worse now in many of these North Indian
Yeah,
districts that we can see. So that is a little alarming.
no, yes, exactly.
Yeah.
Oh, okay, so maybe so what are the some good resources, literature, website, or journals, let's say, or magazines for the kids, let's say high schoolers or undergrads that
Okay.
which are making a change that we can recommend? Like if you
For
have,
science, I was just thinking about it, and then I remembered that one of the books that I keep giving a lot of kids that I know about is this. There's this book called by Lucy Hawking and Stephen Hawking. It's called George and some.
some,
There are two,
yeah,
three books of them.
yes,
And they're very, very nice for children to get interested in science. Very well written books. Other books which I know but maybe old are things like George Gamow, 1, 2, 3 Infinity.
yes,
I don't know if you're familiar with that. Martin Gardner's books. Douglas Hofstadter, but that's a high level.
high level, yes.
Novel Eshelbach.
Maybe I'm for undergrads and master students, it's still very
Yeah, for
interesting.
master students, it should be fine because I think
Yeah, for the high schoolers, yes.
for high schoolers it's a little tough. But I think Hofstadter's articles and he continued after Martin Gardner's job in Scientific American.
Yes.
They're very good. He writes very well. In fact, he's again another of my heroes because he had come to Stony Brook when I was a PhD student there. And he did this thing with Bach, where he had a pianist with him. And he explained how all those things in Gödel Bach actually are
Yes.
happening. So it was an excellent talk.
Okay. So how important has been the impact of these literatures, like you mentioned that you have you like Douglas Hofstadter, Richard Dawkins. So how they impacted you? Like say, how did they inspired you to do something, or it was just like yeah,
So actually, I don't know, inspired directly in physics, perhaps not, but more that it is like, I mean, they're intellectually very challenging. So one feels that you learn to put in the effort to try to understand these things,
understand. Yes.
right? That itself.
Yeah. So, okay. So, considering your exceptional journey and experience that you have mentioned during our conversation, so what advice you give to the young minds of our country, like the final message that
Okay. Something like a final listen. Okay, one of the things I really wanted to say, let me say this here, that even for, I mean, as I was already telling you, that people, when they come back, they should have an open mind as to what they want to do, because there are lots of challenges in the country.
yes,
The point I also want to make is that they should have they should not have a narrow definition of success. I mean,
right,
they should have a kind of a wide, open-minded definition of success. I'm saying this particularly because, I mean, under very recently, we know of a lot of people who've had a lot of depression, and particularly young people, students, postdocs, uh, who have been going through, partly because of COVID and partly because of general pressures of uh,
yes,
life at that stage. In IISc, I think a couple of people committed suicide in the last few months. And I very strongly feel that part of the reason is because they define success very narrowly.
very narrowly, yes,
And it is not that, I mean, success, even in our profession, even as a scientist, doesn't mean that you have to become a professor. It is one way of becoming successful, or there are as many other ways. If you want to become a scientist and you want to live your life as a scientist, there are many other ways. One of my postdocs became a journalist, science journalist. She's doing very well. She's very happy,
yes.
right? It is not that you should just focus on getting your next postdoc, next this thing, and so on.
Next,
So I would tell this to all younger people. I mean, there are many, many ways of being successful. Don't close your minds to the other.
that's a very good advice. I mean, I must say. So, okay, thank you so much. It was really nice to meet you, and thank you for I mean, very impactful points that you discussed during our interview. So, yeah,
Thanks a lot for having me here. I enjoyed it.